All right, so we're going to do exponential regression. So earlier this year we have done linear and quadratic regression. So now exponential, it's just basically a little bit of a different button. So we have this data here. It says the amount of lost revenue from tickets not sold for a concert has an exponential relationship. And it's shown in the table below. Calculate the exponential model equation for the relationship between y, the amount of lost revenue, and x, the price per ticket. So if you look at what's going on here, as the prices go up, the amount that you lose goes up, okay? So this looks like it's going to be a growth, right? So as you move to the right, your amount lost goes up, loss in revenue, okay? So I expect an exponential growth here. So 25, 35, 55, 125. So let's go ahead and do this on our calculator first. Where is that calculator? Whoopsie, nope. Oh, where is my calculator? Oh, there it is. So on the calculator, you would go to Stat, you go to Edit, and I need to go ahead and clear this list. Go to the top. Oopsies, Stat, Edit, Top, Clear, Enter, Clear, okay. And this one's a little bit different. Okay, up here, Clear, Enter, Clear, okay. All right, so what was it? 25, 35, I forget. 25, 35, 55, and 125. All right. Let's see, these are harder to remember here. Let's see, I think I can do split screen on this, can I? I don't know how to do split screen. Anyway. All right, 21, 28, 50, 60. Shoot. One 28, 50, 60, 40, 325. Okay, all right, so we're trying to do exponential regression. So let me get out of here, second quit, just back to my main screen there. And to do that, you're gonna do Stat, go over to Calculate, and you wanna go all the way down to number 0, I think it is, yep, exponential regression. So you're gonna go ahead and leave everything as it is, except you're going to store. You want to store your regression in alpha trace, and you choose Y1 because you want to be able to store it and have your equation there. Okay, so look at my answer. There's my a times b to the x, the basic form of an exponential regression, and my a value is 997. We're going to say 0.2, and look at that b value, it's bigger than 1. So 997.2, and 1.03 is my b value. 997.2 and 1.03 to the x. All right, so like I said, this is bigger than 1 because we're seeing a growth right here. And now that we have that, it says use your model to predict the amount of lost revenue if the price per ticket is 100. So I kind of know, it's between 5,000 and 40,000, but I don't know the number. So I'm gonna basically plug 100 into here, but I'm gonna make the calculator do it. Now, since I have my equation, if I look in y equals, the equation's in there. So I'm going to make the calculator put it in there for me. So I do alpha trace, enter, and parentheses 100, and there's my answer, 19,220.97. And that's in dollars. Okay? So that's how you do that with your calculator. Now let's look at Desmos. All right, so in Desmos, you're going to want to create a table. So plus sign, table, and put your numbers in. So 25, 35, I think it was 55, and 125, 25, 35, 55. Yep, 21, 28, 50, 60. So 21, 28, 50, 60. And the last one, 4325. Crap. 4325. Okay, so you come down here and you are going to do, you're going to make an equation. So we want y equals, but remember, we don't want an equal sign. We want y1. We want that little tilde sign, so right here, and we want a times b, and we want a power of x1. All right, and there we go. And you can see the exact same answer came up. It's a tiniest bit different. That 993 is a little bit different, I think, but it's perfectly fine. And 1.03 is still the same, so 993.413. And if we wanted to go ahead and see a picture of this, we would have to, there it is. And so the easiest way to get an answer for 100 is to do this. Plug in or type in x equals 100, because that's what we want to happen, and you go and find the place basically where these two things intersect. So where does this red line and this thing intersect? It's, oh god, it's way up here. So I think it intersected like right in here somewhere. Okay, hard to tell. So I guess what we would do is we could do this. Oh, let's see. I would put in, let's see if this will work. A, okay, it knows A is that, times B, it knows B is that, A times B, and then put in power 100. And there you have it. So it knows A and B are the numbers up there, and that's basically 19,225. If I remember, it's close enough. Okay. Desmos is just doing the regression a tiniest bit different, so that's why it's like a little bit different from here, but both are close enough to go ahead and get your answer.